Welcome back to the channel. As always, it's a pleasure to have you back here. And this is Mathematics, your online complete school of mathematics, where we deal and break down with mathematics, making it easy for you to understand. You're welcome. I'm Pendulum, and I'm your tutor on this channel. As you know, if you're following our videos, we are still looking at logarithms, and today we are looking at logarithms involving substitutions. Alright, so if you're new, please do well to subscribe to the channel, subscribe to this channel, and turn on our notifications. Make sure you ring that bell once you subscribe so that when we upload new videos, you'll be notified to come and watch and learn. Our videos are always insightful and detailed. Alright, so welcome. Let's see how we can do this. Remember, as we go on, if you find the video helpful, don't forget to like the video, drop your thoughts in the comment, and share the video to as many people and as many places as you can share. It really helps with the video to go far and more people to see it. All right, so let's get started. Now we're looking at substitutions, logarithms involving substitutions. When we talk of substitutions, we mean an exchange. All right, you remove one thing and put another thing in its place. That's the meaning of substitution. If you watch football, you will see where players are being substituted. One player is taken off and another player is brought on in its place. So that's substitution, exchange. And what does this mean when it comes to logarithms? In this aspect of logarithms, where you have to involve substitution, usually you are given some substitutes. All right, so I'll use football analogy here. Let's say this is your bench and you have some players on the bench, your substitutes. So here we have 3 players on our bench: log 2 base 10, log 3 base 10, and log 7 base 10. These are our substitutes, and we are told to use these 3 to evaluate 1, 2, 3, 4 without table. So these are our starting players. These are our players on the pitch: number 1, number 2, number 3, and number 4. But we are asked to use these 3 to evaluate them. So basically what you are going to do whenever you see a question like this involving substitution is that you are going to find a way to break down what you're asked to evaluate as a product of these substitutes they have given you. These are the only things you are allowed to use here. These logarithms given to you, and probably standard logarithms like maybe log 10 base 10, which is 1. They are the only things you can use to resolve this question. So you must find a way to break down all these things into a product of these logarithms you are given, so that you can now substitute them and put these ones in their place and find your answer. All right, so let's solve this example so that you see exactly what I mean. Let's take them one by one. First of all, we have to evaluate log 42 base 10. Now, like I said, you are going to express 42 as a product of 2, 3, and 7. Now, take note that you must not use all 3 of them. All right, some cases you may only need one. For example, if I ask you to evaluate log 8 base 10, you know that 8 is just log 2 times 2 times 2, right? Base 10. So in this case, you don't need log 3 and log 7. Only log 2 is okay. All right, so you can break this down into log 2 base 10 plus log 2 base 10 plus log 2 base 10. And then you substitute the values and add up. Or you can write this like this: 2 raised to the power 3. That's 2 times 2 times 2. Then, of course, you bring the 3 back here. And you now have 3. You now substitute the value of log 2, 0.3010. Alright, so I just want to point out that you don't necessarily have to use all the substitutes given to you. Alright, but you must use one or some of them, or even all of them in some cases, depending on the question you are given. So now let's look, how can we break down 42, making it a product of these numbers here. Now we know that 42 is 6 times 7, Alright, so 7 is here, but there's no 6 here. We can further break 6 down into 2 times 3. Alright, so that means I can write this as log 2 times 3 times 7 in base 10. And I have not done anything wrong. I just expressed 42 as a product of its factors 2, 3, and 7 because the substitute I have here are 2, 3, and 7. So assuming they have given me log 6 base 10 here, I can just do 6 times 7. So if you're able to break it down like this, you are already on your way because I can now separate this one into log 2 base 10. Remember that multiplication is addition. Alright, and addition is multiplication. In a logarithm, they are interchangeable. So I can separate this like this. Alright, I hope you can see this very clearly. So I have separated this now into log 2 base 10 plus log 3 base 10 plus log 7 base 10. I have expanded this. If you want to go from here back here, it's still the same thing you get. So once you've expanded it like this, you have basically solved the question because now we substitute our given values. So the values they gave us in the original question, we substitute it, and we'll have log 2 base 10 is 0.3010. That's this. Plus log 3 base 10 is 0.4771, and log 7 base 10 is 0.8451. Now if we add this up, let me get my calculator because this is decimal. I can't be doing it by heart. But if we add this all up, if you have a calculator, you can be doing this with me as well so that we'll do it together. And this is going to give me 0.9887. Alright, so that's our solution, 0.987. So the only thing, as you can see here, just break this down as a product of the factors. Now let's look at log 30 base 10. Now again, we are going to break down log 30 and express it as a product of factors. Alright, now we know that 30 is 6 times 5, right? And 6 is 2 times 3. That means I can write this as log 2 times 3 times 5 base 10. Okay, I've not changed anything. This is still log 30. So now I can break this down into log 2 base 10 plus log 3 base 10 plus log 5 base 10. Just like here, we can from here come here. Because of the multiplication, we can change it to addition and separate out the bases. Alright, but then you notice that here we have log 5 base 10. But among the substitutes given to us, there is no log 5 base 10. It's only log 2, log 3, and log 7. So you ask yourself, how else can we express log 5 using logarithms that are already known to us? How can we rewrite this one? Because these two, we have no problem with it. They are given to us. This is the one we have an issue with. So how do we rewrite it using logarithms that we already know? And the way we do that, we know that 5 is actually 10 over 2. Right? 10 divided by 2 is 5. Why are we using 10 over 2? Because those two numbers, 10 and 2, are logarithms that we know their answers. Log 10, 10 is 1. So we know that one. That's a standard logarithm. And then log 2, 10 is given to us. So that's why we're using 10 over 2. We cannot come here and use 20 over 4. We know, yes, that 20 over 4 is 5, but we don't know log 20 base 10. Alright, we don't know log 20 base 10. It's not given to us and it's not a standard logarithm. So we use 10 over 2 because log 10 base 10 is 1 standard and log 2 base 10 is given to us. So that means I can rewrite this one. I hope you got that explanation. That means I can rewrite that last one as log 10 over 2 base 10, which I can also break down like this. Not this first two is still intact. Now this is division, 10 over 2. You know that with logarithms, division is multiplication. It's the same as multiplication. So that means I can break down this one into log 10 base 10, that's the top one, minus division log 2 base 10. Meaning I can write it like this, and I have not changed anything. Because if I bring these two together, I'm still going to pick one log 10, and then I'll have 10 divided by 2. If I want to simplify it, this minus to change to division. So if I want to expand from here, it will come like this. Then here I can now substitute our values, our given values. Alright, so we know that log 2 base 10 is given to us as 0.3010. Log 3 base 10 is 0.4771. Log 10 base 10 is 1. It's a standard logarithm. Any number to the same base is 1. The logarithm of any number to the same base is 1. And then minus log 2 base 10 again, 0.3010. So if I do this, my final answer is going to be 1.4771. Okay, basically just this plus this, because 0.3010 will minus this one, so these two will basically cancel themselves. So you're just having 1 plus 0.4771, which is 1.4771. So this is the answer to the second question. Alright, so I hope that's clear. I hope you understood it. It's not difficult, you just need to pay attention and remember that whatever you're doing, you must use one of these three logarithms or a standard logarithm like log 10. So you cannot go and import any other logarithm and use log 6 or log 7. No, you must use these ones given to you or a standard one like log 10 base 10. Alright, so let's look at this one. Log 0.27 base 10. Now I can rewrite this as log 27 over 100 base 10, right? 0.27, I want to write it as a fraction. Alright, so I can rewrite it 27 over, this decimal is 1, then 2 zeros. That's how I got this. Converting from decimal to fraction should not be an issue for you. Now, let's go on. If I separate this, I'm going to have log 27 base 10 minus log 100 base 10. Alright, if I separate it, if I expand it, alright, so log 27 base 10, division is minus log 100 base 10. Okay, now what do I do here? I can write this as log 27 is 3 cube base 10 minus 100 is 10 square base 10. Alright, so I can write it like this, and I've not made any error. 27 is 3 raised to power 3 base 10 minus 100 is 10 square. Alright, so if I continue, of course, from the power law, you know that this 3 can go to the back, this 10 can go to the back. So like I was saying, from the power law, we can move this 3 to the back. So we have 3 log 3 base 10 minus These 2 also can move to the back. So you get 2 log 10 base 10. Now if we just substitute our values, we have 3 log 3 base 10 is given to us as 0.4771 minus 2 log 10 base 10 we know is 1. Alright, so let's multiply this with my calculator. We have 3 times 0.4771. Okay, so this is 1.4313 minus, please do this together with me so that we can confirm it to minus 2, and this will give me minus 0.5687. Right? So the answer to this question is minus 0.5687. So this is actually a simple question. The only thing you need to take note of is expressing this like this. Then you remember that 27 can be expressed in powers of 3. We have 3 here, so that's not an issue. And 100 can be expressed in powers of 10. Because this logarithm is in base 10, that one is also not an issue. Alright?